So now let's move on to the next code template, polynomial regression. Well, here that's the same, the same data preprocessing phase with first importing the libraries, then importing the dataset where you only have to enter the name of your dataset here, and then splitting the dataset into the training set and test set. Then, of course, we train the polynomial regression model on the training set. So that's exactly like what we did in this part 2. When we built it, you recognize degree equals 4. That's exactly the same code. Then we predict some test set results just to compare our predictions and the real results. And finally, we will evaluate the model performance, and I will reveal very soon how to do that. Okay, so that's for polynomial regression. Once again, very generic. You just have to enter here the name of your dataset, and then this code template is ready to be deployed. All right, then support vector regression. So here that's the same. First, the data preprocessing phase where we import the libraries, then we import the dataset, but then remember we have to reshape our dependent variable vector y because we have to feature scale it, right? Because we're doing regression. So the dependent variable vector has continuous numerical values, and therefore for SVR, we need to scale the dependent variable vector. That's exactly the same as what we saw together when building the SVR model. Then I added this, of course, in order to split the dataset into the training set and test set so that we can indeed evaluate the performance of SVR and compare it to the other models. Then, of course, we have feature scaling, compulsory for the SVR, with, remember, our two scalars, one for the matrix of features and one for the dependent variable vector. Then we train, of course, the SVR model on the training set. You know this very well, we did it together. Then we predict the test set results just to compare and have an idea of how good are the predictions of new observations. And finally, we will evaluate the model performance with R-squared. No worries, we'll get to that very, very soon. So that's for the SVR. Then for decision tree regression, well, exactly the same. The data preprocessing phase first with no feature scaling, right? Remember, we don't need feature scaling for decision trees. So once again, we only have to change the name of the dataset here. Then we split the dataset into the training set and test set. Then we train the decision tree regression model on the training set, exactly the same as we did in our implementation when we built it together. Then we predict the test set result in order to compare our predictions to the real result in y-test, and that's in order to have a first idea of the performance. And then, of course, we will evaluate the model performance with R-squared. And finally, we have the exact same data preprocessing phase where you only have to enter the name of your dataset here, and then we train the random forest regression model on the training set with the exact same implementation as how we did it together. Then we predict the test set results in order to get a first idea of the performance. And finally, we evaluate the model performance. All right. So as I told you, you have purely generic code templates which you can deploy for any of your future datasets as long as they have first the features and last the dependent variable, and as long as they don't have missing data or categorical data, in which case it's still fine. You can use your data preprocessing toolkit. But there you go, you have this code template, and now I'm going to show you how to evaluate your regression models using the R-squared coefficient. All right, so let's start with R-squared, that final cell in each of the implementations, evaluating the model performance. Let's see how we're going to do this. Well, as I also want to train you on how to be independent in machine learning, we're going to pretend once again that I actually have no idea on how to evaluate the model performance of regression models, and therefore that I have to go to the documentation online to figure out how to do it. All right? I'm just training you to be independent and quickly find an information whenever you need it.